All right, so in the last video, we derived the equation in the red box down in the left corner. X minus h squared plus y minus k squared equals r squared, where h and k are the center and the radius is r. So this one's a super plug and chug easy example. Find the equation of the circle centered at 2 comma negative 4 with a radius of 5. So you're literally just going to plug these numbers into the formula. So our h is 2, our k is negative 4, and then our radius of the circle is 5. Just plug and chug. So we're going to plug in x minus h, so x minus 2 squared plus y minus a negative 4. So this is going to become y plus 4 squared. And then it's going to be 5 squared, so 25. Okay, so we always square that radius over on the right. And notice from the center to the equation that the coordinates kind of change sign in the middle because of that subtraction from the distance formula. Okay, so x minus 2 means it's a positive 2x coordinate, y plus 4 means it's a negative 4y coordinate. All right, so let's take this equation over to Desmos and just make sure that graphs the circle that we meant it to. All right, so here we are in Desmos. I'm going to graph that equation we just came up with, x minus 2 squared plus y plus 4, that was our negative 4y coordinate squared, equals, and we need a 25. All right, so let's take a look at this. So this was supposed to have a center at 2, negative 4. Let me just plot that point so it looks a little bit more obvious. 2, comma, negative 4. All right, and then that looks perfectly in the center of that circle. And if you count the tick marks from that center, that purple point out to the sides and up top and down below, you'll get 5 tick marks. This is exactly the circle that we meant to graph. All right, so our equation works. I'm going to show you one more circle, another circle. Let me turn this guy off. All right, so this circle looks like it has a center at negative 3 comma 1 and a radius of 2. So you should feel at this point that you know what the equation of this circle looks like, right? You could plug in that negative 3 comma 1 into the formula for the center and the radius of 2, and you'd have the equation of the circle. All right, but if I show you the equation that the circle came from, it doesn't look like that really at all. I mean, it's got x squareds and y squareds in it, but what's happened is that some jerk has come along and kind of foiled out those parentheses and gathered up the like terms. So if you're looking at that equation, if you didn't have the graph in front of you, you couldn't tell that the center was at negative 3 comma 1. You couldn't tell that the radius is equal to 2. You just would have this pile of x's and y's. So now I want to show you, if you run across an equation like this, how do you reverse engineer that form of the circle that tells you the center and the radius for free? All right, here's the equation that I had graphed in Desmos, which clearly gave us a circle, but the equation didn't look like the equation of a circle. So the technique to get from the equation I've got to the one that I want is one that you may have learned before, but probably forgot, called completing the square. And completing the square involves adding some magic numbers to the equation. But the first thing I'm going to do is move this 6 over to the right. So we're going to move the number part over to the right because we want that to be that radius squared. All right, so I'm going to rewrite this as x squared plus 6x. And I'm going to leave a blank where I'm going to add a magic number. And I'll tell you what the magic number is in a minute. I'm going to do the same thing after the y. So I've got minus 2y. I'm going to add a magic number. And then I've got negative 6 over here on the right. Okay, so the magic numbers that I'm going to add, and see, for the x bit, it's going to be a 9. And for the y bit, it's going to be a 1. All right, so I'm going to show you how I got those numbers in just a second. The reason why I like these numbers and why I call them magic is because it makes these things factor in a very particular way. Okay, so I'm going to go ahead and factor the x stuff and factor the y stuff. So I've got x squared plus 6x plus 9 factors to x plus 3x plus 3. Copy down that plus sign. The y terms are going to factor to y minus 1, y minus 1. And I've still got this 6 hanging out there on the right. Okay, so that 9 and that 1 were magic numbers that made these things factor into a perfect square, because now I'm going to be able to write that as x plus 3 squared and y minus 1 squared, which is what the equation of a circle looks like. All right, but I can't go around adding 9s and 1s just because I feel like it. Otherwise, I'd add a few 9s and 1s to my paycheck. All right, so up in the step where I did the magic number, I would have to add that 9 and the 1 over to the right side as well so that I don't change the equation. So let's make sure that we add 10 to that negative 6. All right, and then let's just rewrite this. So I've got x plus 3 squared plus y minus 1 squared, and then I've got 4 on the right. And now that looks like the equation of the circle that we saw on Desmos, right? It looks like it has a center at negative 3 comma 1. It looks like it has a radius of 2. It looks just like we expected it to. All right, so how did I find those magic numbers? Let's kind of draw a box over here on the right. All right, so if you've got x squared, could be y squared too, plus we're going to use a bx, and you want to complete the square. All right, so that magic number is going to be whatever that b coefficient on the x or on the linear term divided by 2 and then square it. And so b divided by 2 squared. So if I go back to my problem here, when I had 6x, what I did is I took that 6 and divided it by 2 and then squared it. 3 squared gave me 9. And then this term here, I took that negative 2 coefficient of that linear term, divided by 2, and then square it. So negative 1 squared gives you positive 1. All right, so since you're squaring those terms, it's always going to be a positive number that you're adding to both sides. Completing the square, you're never going to subtract from both sides, always adding. All right, so this is how we complete the square. All right, and it's worth noting that the coefficient on the x term has got to be, sorry, the x squared term has got to be a 1. This magic number does no magic if it's 2x squared. So we'll have to talk about what to do if we've got a coefficient on the squared term when we meet together in class. All right. The last thing I want to leave you with is the equation of an ellipse. All right, so here's the standard form of the equation of an ellipse, and it kind of resembles the equation of a circle, a little bit different. An ellipse is an oval shape, so it doesn't really make sense to talk about a radius, so there's no radius squared. We do have these a and b numbers being squared, and those do tell us a lot about the shape of the ellipse. The h and k should look very familiar. They have the same role in the ellipse as they do in the circle. This still is going to tell you where the center of the circle is at h comma k. And so I've posted on our Moodle page a link to a Desmos page that has this equation in there with sliders for H, K, A, and B that you can kind of move around. And I want you to play around with that a little bit before you get to class on Zoom and try to decide what the A and the B are telling you about the shape of the ellipse. I'll see you then.